Well, hello, pre-calculus students and seekers of general truths. Let us take a look at another example of logistic functions. Springfield High School has 800 students. On February 2nd, there were 16 students infected with the flu. On February 16th, there were 200 students infected. So this flu is spreading quite quick. What type of function should be used to model the number of infected students as a function of time, and why? Well, not just because we're learning about them right now, but in general, logistic functions make the most sense because the infection is going to spread quickly. But there is a limit to how many people can be infected. If you notice, there are 800 people in the school, so this is the most that can possibly be infected. Part A, write a function that models the number of, or part B rather, write a function that models the number of infected students as a function of time. So rather than mess around with the dates from the start of the year, we're going to say that let t equals 0 be February 2nd. So our table of values are going to look like this. When t is 0, there are 16 people infected. And then on February 16, which is 14 days later, there are 200 people infected. And we know that a logistic function has a limit to growth, or a carrying capacity. Limit to growth, I think, makes more sense here. So this limit to growth is going to be 800. Now, let's analyze this, and let's use the information that we have. So the first thing we do is substitute in 0 for t and 16 for p of t. And then we're going to solve for one of the missing letters here. So let's get right to it. E to the 0th is just 1. In fact, anything to the 0th is just 1. So that whole term cancels out, and all we have left here is just a. Then, I guess we call it cross multiply. Multiply both sides by this denominator, and divide both sides by 16. This is what we get. To get a by itself, subtract 1 from both sides, and we get that a is equal to 49. So now we can update our function. P of t equals 1 plus 49 e to the negative kt. And we need to use the other data point here in order to solve for k. So set 200 go to p, but substitute in 14. And let's work out all of the detailed algebra. So divide both sides by 200 and multiply both sides by this denominator. Subtract 1, because 1 subtracted from both sides. And then multiply both sides by 1 over 49. Put the natural log of both sides. So the natural log of the left side and the natural log of the whole thing on the right side. And when you take the natural log like that, you know that you can use the power rule of logarithms to pull the exponent down to the front here. And natural log of e, remember natural log of e is just 1, so in this next line we'll remove it. Yeah. And finally, in our last step, we multiply both sides by 1 over negative 14, and that gives us a k value of 0.199 here. So our final equation looks like so. Now, if you're doing this on a calculator, I recommend you saving this into one of the constants in your calculator, so you don't have to be typing it and retyping it your pause, but it will have the potential for minor errors. So that's our function. Now, moving on, the principal has decided to close the school if half of the student population is affected using our function when will the school close. Well, this is our function. Half of the population of the students is 400, and we're going to solve for t. Now, rather than going through all of the messy algebra again, I give you the graphical solution. So I've typed in the function into here. And again, you can type this into your calculator, just be careful how you type it. And also, have some sense of, have some context to it. The scale here is going to be 0 and 800. And then when you have your function typed in, just test a few values. So if I type in p of 0, it should give me 16, right? That was our initial value. Now if I type in p of 14, or this is February 16th or 14 days later, it should give me a value of 200. And this is a rounding error. So now, if I want to find out when the population will reach 400, I set a horizontal line where y is equal to 400, and I find the intersection. And so I get that t is approximately 19.5. Now remember, this is days after February 2nd. The point of reference here was February 2nd. So that's about 19 and a half days later. So we can say, well, February 21st or 22nd, somewhere between those 2 days is when the infected number of infected students will reach 400. So here you see an example of applying a logistic function to a real context. Remember, if there's like a limit to how much it can grow, then a logistic function is really a good use. And you can work out all of the messy algebra, but you can also keep in mind to use the graphing calculator and graphical tools. Here, this is one case where a graphical tool, knowing how to use it really works well. As always, keep working hard, and for clarification when you need it. Thank you for